virtual day or asynchronous, whatever they're calling it these days, I asked you guys, you watched a video and did some delta maths, right?
Yeah.
How'd the delta math go?
Pretty good.
Was okay?
Yeah.
Was what?
That was good.
Was good? Okay. Uh-huh. All right. So what I passed out to you guys here at the start, this is the same sheet that I referred to on the video from the asynchronous day. It's just a physical copy because sometimes that just makes life easier to have a copy in your hand to look at. What we're going to do here today is we're going to just kind of do some more examples of doing this process. So we're going to be working on numbers 7 through 14 from the homeworks. We're going to do this today in class. I'm going to call on random people to kind of help me out doing this. So what we'll do, we're just going to kind of go through one problem at a time. And now these problems are a little bit more, or some of them anyways, are a little bit more in-depth than the things from the delta math. But the delta math, if that was easy, that's good. That's a nice, easy starting place then to just get comfortable like using the identities. These problems now we're going to add a second wrinkle in. That second wrinkle being that there might be algebra things to do in addition to using identities. So when I say algebra things to do, I mean like combine like terms or make a common denominator or factor or reduce, like reduce a fraction kind, like stuff like that, okay? So you're going to be looking out for either things to factor or, algebra things to do or identities to use, okay? And I'll kind of help you out a little bit as we go. So we'll just kind of go and do like one step at a time. I'm going to call on some random individuals. I have my random student generator all fired up and ready to go here. So our first problem here is cotangent u times sine u. Nick, you are my first random student. First up, would you rather do an identity or an algebra thing? What algebra thing do you see to do? Would it be?
Oh my gosh.
We're doing problem 7.
Okay. Combine and use. Could I do that?
No, because cotangent u, the u is inside a cotangent, and sine of u, the u is like inside of sine. So like you can't separate those out algebraically. You rethinking what you want to do?
Yeah.
You thinking identity?
Yeah.
Okay, I think you're right. So look at your identity sheet. You want to look for either something where you can turn cotangent into something that has a sine in it, or if you find an identity that has a sine in it, or an identity turns sine into something with a cotangent in it.
Would it be cotangent theta equals 1 over tan theta?
Well, you could use that, but the problem is that doesn't have you're eventually going to want to combine some stuff together because we want to get this down to a single trig function. So I want to look for a cotangent identity that also has a sine in it somewhere.
Would it be the tan parentheses pi over 2 minus theta? That one?
No, because we don't have pi over 2 minus u inside of any of our parentheses.
Would it be the one where it's like cosine theta over sin theta equals CSC theta over SSC theta?
So you're going to use Q2, and Q2 has two sets of equal sign, right?
Yeah.
So that means you could say that cotangent theta equals cosine over sine, or you could say cotangent theta equals cosecant over secant.
Okay. So
Which
we use the first one, right?
Yes, because it has the sine in it. And I'll write the sine u is then just sine u over 1, because if I have two fractions multiplied together, that makes more sense than just leaving it as times sine u. Less likely I will do something silly if I write as a fraction, right? All right. My next volunteer is going to be Cameron. Well, we're still going on this problem. You're just going to help me with the next step. So Cameron, do you want to try to do an algebra thing or an identity thing?
Algebra.
Great. What algebra thing can you do here?
Cross multiply.
Okay. What do you mean when you say cross multiply? I don't think that's what you mean when you say it. But what do you mean when you say cross multiply?
Bottom, top, bottom.
Okay. So you can do that if that's a solving technique. If this was an equal sign, then you could do like a cross multiply thing if you're trying to solve. But that's not how we multiply fractions, right? So how do we multiply fractions? By dividing. What do you mean by dividing? Okay, so if this was like 3 over 2 times 2 over 1, what would you do? But they're not being added. It's just being multiplied, right? You need common denominators if you're adding or subtracting fractions, but not if you're multiplying. So let's focus on the simpler version here first, okay? So you can do this. That's really what you want to do, right? So you can just reduce. So if we do the same idea up above, what can we do?
Reduce sin A and sine A.
Yeah, those are supposed to be u's, but that's my penmanship, so. Right, so the sine u's cancel out, right? We reduce those out of there. What do we have left then?
Cosine A and then over 1.
Yeah, but we won't even bother with the over 1, right? So we have cosine u, got it down to a single trig thing, no fraction, that's done. Does that feel okay? Emily, you're making a lot of faces here. What's going on? Okay, where did I lose you at?
Where did those middle numbers come from?
The 3 over 2 and the 2 over 1?
No, like an actual top part.
What middle
Yeah.
numbers?
Like, or like the cosine u over sine.
So
I wanna do that.
what Nick did was he used Q2 to replace cotangent with cosine over sine. So if you look at your identity sheet and you find Q2,
Yeah.
it says that cotangent is equal to cosine over sine. So you replace the cotangent with cosine over sine.
Oh, okay.
Do you see it now? Okay. That was the issue?
Yeah.
Okay. You feel better?
Yeah.
All right. Let's go to the next one then. We have okay. Let's see who's going to be my next victim. Gabby. We're working on number 8 here. Identity or algebra? Identity, okay. Which identity do you want to use? So the identities are on your identity sheet I just passed out to you. So that's where you'd want to be looking. So you could use P2 to replace cosecant squared with 1 plus cotangent squared. Probably don't want to do that though. So although that's valid to do, you probably don't want to do that. Let me explain why. The goal is to get this down to a single trig function. So typically we wouldn't want to take one thing and replace it with two things. We want to be getting less stuff in general. So unless you have plans for like, oh, if I do that, then some stuff can cancel out, we probably don't want to replace one thing with two unless you see later on that something good can happen, right? Like up here, when we replaced the cotangent with cosine over sine, it was okay to do that because we saw that the sine was going to cancel. So here, if you replaced cosecant squared with 1 plus cotangent squared, there's nothing that's going to cancel by doing that. I probably wouldn't want to do that.
Would it be Q1?
To do, what are you going to do with Q1? You're going to replace the tangent pi over 2 minus x with sine pi over 2 minus x over cosine pi over 2 minus x? I mean, you could do that. It would not be wrong to do that, but it's not helpful because, again, you're swapping one thing for two and nothing's going to cancel. Yes. So if you're looking to do an identity here, the first thing I'd want to do is I look inside at the arguments for my trig functions. So two of them are just x's, and the other is pi over 2 minus x. Do I have an identity where I can replace that pi over 2 minus x with an x? You're on the wrong page. So look at the cofunction identities, Gabby.
Yeah.
Look at the cofunction identities.
Would it be C3?
Do you have cotangent of pi over 2 minus x?
It could be
C6. That's the one you want, yes. So that's going to allow us to replace tangent of pi over 2 minus x, which is cotangent x. So that's good. Now all the inner parts are the same. That's a good identity thing to do. Okay. So in general, whenever I see something like this, my first look is to be to the cofunction identities. Whenever I see one of those guys in my problem. And really that'd be the only time I'm going to be interested in the cofunction identities is when I see one of those guys.
The pi over 2
minus x.
minus x.
Yep. So that's my cue to know to use a co-function identity. It's really the only time I'd be using those identities. All right, Max, you're next.
Alrighty. Which one we got?
So we're down to cotangent x times cosecant x over cosecant squared x. Algebra identity.
Cosecant squared x, is that
That's on the bottom, yep.
So then can we put that in the square root to reduce it?
So if I have like 1 over 4, is that equal to 1 over the square root of 4?
No.
No. So you can't just like square root part of a fraction willy-nilly because it changes the identity or the value of the fraction, right?
Yeah.
Are you thinking algebra or identity here?
I'm going to be 100% honest with you. I think the only way forward with this is algebra.
I think that's what I would do here. Agreed. Let's do an algebra here.
So then what we're probably going to have to use the CSC squared at the bottom to try to get rid of that CSCX at the top.
Right, so we can reduce the fraction. That's exactly the right idea. So you can think about it like that.
Now,
Nope, you're done.
well, I'm done.
That's it. You did we found an algebra thing.
Time.
That's enough.
Yeah, how much you struggle on this?
So far, so good. Massimo. We got cotangent x over cosecant x. What should we do now? Identity or algebra? Probably not. So let me explain why I don't think there's going to be any algebra thing here to do, right? Because that's an important question. Like, what are you looking at to be like, I don't think so. When I look at that problem, it's just a single fraction, right? Just one thing over another. Are there any like terms to combine? Could you make a common denominator? No, there's not two fractions to add together. Is there anything to reduce? No, they're different things. So like, there's no algebra thing for me to do here. Like, my list of things that I could choose from is kind of exhausted. So I'd be thinking identity. And let me make this suggestion for you. The way that I would think about this when I'm about to use an identity and I have a fraction, I typically want to think about it as like the top over 1 times the 1 over the bottom. That usually makes life a little bit easier to see which identity I'd want to use. So it would be, I want to be picking from one of those two spots, absolutely. So I'd be looking to see, okay, is there a way to rewrite cotangent so that it has a cosecant in it? Or can I rewrite cosecant so it has a cotangent in it? So I'm going to look at those identities, the Q's and R's, and see if I see a way to do either one of those two. So I don't have a tangent. I don't have a 1 over cotangent. I have cotangent over 1, which is different, right? Yes, let's use Q2. Q2 allows us to rewrite cotangent as cosecant x over secant x. Okay, good. Thank you, Massimo. Next person is Kiera. All right, so we're down to this. We have cosecant x over secant x times 1 over cosecant x. Great, I agree. Let's do an algebra thing. What algebra thing can we do? So let me just go back here for a second. This looks very much like what we had right here, right?
Oh, like,
Reduce. Yeah, what can we reduce?
like recipients.
Good. And what do we have
One
left?
recipient X.
Excellent. Great. So next person is going to be Sam. So we're left with 1 over secant. What can we do now?
We'll do the reciprocal.
Yep, which reciprocal?
R2.
Yes. So just turn that into cosine x, and we're done. Easy peasy.
So for these problems, like we're just trying to reduce everything into one number, or not number, but like one.
One thing. Yep. That feel okay, Sam?
Is that a pattern of doing like the
Sometimes you'll be like, you might do 2 or 3 identities and then have some algebra cleanup. Sometimes the order doesn't really matter. So on this problem, you could have started just by reducing first and then doing your identity. Or you could have started by doing identity first and then reducing like we've done. So sometimes the order doesn't really matter. Sometimes there's like a super shortcut. We'll see one here in a minute that I think that nobody will see the shortcut on, that I'll have to show you at the end after we've muddled through it the hard way. But in general, we're going to be, you often will be, doing one and then doing the other. Oftentimes you'll alternate back and forth. That's not uncommon. So number 9. All right, Anthony, you are up. Algebra or identity? Great. Which identity would you want to use? Close. The top is. Which identity are you trying to use here? So P1, right?
Yeah.
Okay. So if I look at P1, if I say like I subtract cosine squared from both sides, so that sine squared is equal to 1 minus cosine squared is also P1. Or if I had, say, subtracted sine squared from both sides, I could say cosine squared is 1 minus sine squared. Also could call that P1. If I were you, on my identity sheet, I would write out the alternate versions of all 3 of the Pythagoreans, like doing the same thing, just like subtracting things from both sides, just so I have those written down on my paper so that I would be looking for them. But that's exactly what we would do here, Anthony. You did it. Okay, next person, my next volunteer is Ethan. What are we going to do next, Ethan? Algebra identity.
Identity.
Probably not.
Algebra.
What algebra thing can we do here? Let's see if we think about it this way. What if we think about it as just like 3 squared over 3? What does that turn into? Doesn't turn into 1. What's 3 squared?
3 squared.
Divide by 3. So what happened here? We did like one of those guys, right? So look at what we have.
So do you like times it by sine x.
We do the exact same kind of reducing. And we're left with just sine x. Right? You see the similarity in the two? Again, if you're not sure, like, how do I do this algebraically? Think back to just numbers. Most of us have the right idea if we turn things into numbers instead of like a bunch of letters and symbols here. But it's the same set of rules, the same things that would be okay to do with a number are the same things you're going to be able to do algebraically with the symbols. So if you're kind of stuck, think about what it would look like with just some numbers. So like I just replaced the sine x with 3s. I said, okay, what is that? What can I do with that? Tommy?
I have a question. So how'd you get to the blue with sine squared x over sine x? Like I know you subtracted on both sides, but how come like the 1 isn't there anymore?
So I said that 1 minus sine squared is equal, or 1 minus cosine squared is sine squared, right? So over here I have 1 minus cosine squared is sine squared.
Oh.
So I've just replaced one with the other.
Okay.
Okay, Ethan? Sure. Does that feel good now, Tomasino? Okay. All right, let's see. Next problem. Yes, Anthony?
When we have our test, when we have this.
Yeah, you don't have to memorize this. Naya, number 10. Tan over cosecant squared x plus tan over secant squared x. What do you want to do here first? Algebra or identity? Okay, what identity are you thinking you want to use here? You could, but I wouldn't. The only time I would use an odd even identity is if I have like a negative x inside my trig function. And I don't have any negative x's anywhere, right? So that's the only time I'm going to look for an odd even. Majority of the time I'm going to live with like reciprocal quotient Pythagorean are really kind of where my bread is going to be buttered. R3. So you want to turn the tangent in the numerator into 1 over cotangent. So you're going to have a fraction on top of a fraction. I mean, I'm just asking to make sure, like you can do that. Is that going to accomplish anything for us, though? Like, is that going to allow us to cancel something out that we couldn't before? Not really, right? And really, that's what I'm looking for if I'm using an identity, is I don't want to change something unless it's going to cancel something else out. Or I'm just like at an impasse where I've exhausted all the algebraic things I could possibly do. We just got to start changing some stuff here because this needs to go together somehow. To do... What's Q2 going to get us? I don't even see a cotangent on here to use Q2 with. May I make a suggestion? Let's do an algebra thing first. So I see 2 reasonable algebra things that I would do as my first step. What do you see?
If you reduce the top.
When you say reduce the top, what do you mean? Like what's going to cancel? So you want to do this. Does that look like something you can do? No, right? That'd be equivalent of saying like 2/3 plus 2/5. Oh, that's just going to equal 1/3 plus 1/5, right? Well, that's not right. You know what I mean? So we can't do that. Do you need some other options in the algebra plate to hear again? Absolutely. So things you can do, you could combine like terms. You can reduce. You can factor. You could FOIL. You can make common denominators. Those are all like the normal kind of algebra things. And in fact, two of those things that I listed would be good things to do here. Let's think about this another way then, okay? So let's say that we just have 2/3 plus 2/5. If I asked you to like do this problem, what would you need to do first? Great. Let's do the same thing up here, okay? What would your common denominator be? For the blue problem first. 2/3 plus 2/5. What's the common denominator going to be? Okay, great. 3 times 5, right? 15. What's the common denominator going to be for the red problem then? Well, you got 15 was the common denominator over here, right? So it was this one times this one. What do you think the common denominator is going to be for the red problem then? Yes, that is correct. So we'll multiply the first one. Actually, let me write that in a different color. Oh, thank you. Roman, this is yours. Thank you. Cameron? Sure. Nice. Is that okay? So far, so good? So let's then write this. So we have like secant squared x times tangent x plus tangent x times cosecant squared x over secant squared x times cosecant squared x. Emily.
Oh my gosh.
Algebra or identity now?
Algebra?
Okay, what algebra thing are you going to try to do here?
Like,
Like what, for example, are you going to
like
cancel?
the, like, terms like the secant squared x and the
So you think we can do this?
yeah.
Okay, so let's say that we have, let's just turn this into numbers. So So you're saying that I can do this, right? Okay. So if I don't do that, I'm going to have 6 plus 15, that's 21, over 2 times 5, that's 10. If I do that, I'm going to have 15 plus 3, that's 18 over 5. Is 21 over 10 equal to 18 over 5? No, right? This one we know is right because we didn't do any reducing to get it. This one has to be wrong. Can we reduce this way?
No.
No. What's the difference between this problem and the previous problems where we did do reducing like that? What's different in this problem than those previous ones that allows us to cross off tops and bottoms then, but not tops and bottoms now? Joey.
Oh, were they not being multiplied?
Yeah. The addition here, because my numerator has 2 things added, I can't cross things off from just one piece of the addition problem. Okay, the previous problems when we did that, no addition going on, right? So if there's no addition, yes, go cross off crazy. If you have addition or subtraction, gotta be very careful. Is that okay, Emily? You understand the difference?
Yeah.
Okay. Very common algebraic mistake for students to make. But that's not going to work, that type of reducing. Is there a different algebraic thing you want to try, or do you want to use an identity? Okay. Which one were you? What algebra identity? Okay. You want to hear your plate of options again?
Yes.
Okay. Combining like terms, reducing fractions, common denominators, factoring, foiling. Those are the usual. Yeah, so the like terms to combine would be the numerator,
Yeah.
but this and this are not like terms, right? It's like
Yeah.
y squared plus, or y squared x plus xz squared or something,
Mhm.
and they're not the same. So we can't do that.
In fact,
Yes. What can I factor? So if I have like 2x plus 4, what can you factor from that? 2. Because the 2 is in common to both parts, right?
mhm.
What's in common to both parts of the numerator? Great. So that's what's going to get factored off. What's left in the numerator?
Secant squared x
Mhm.
plus cosecant squared.
Great. And the denominator still stays the same. Okay, so you can do that. Is everybody okay there? Emily, you see what we did? Okay. All right, let's see who's next. Joey. Yeah, I know.
We use Q1.
Okay. So you're thinking identities. You picked Q1 to turn tangent into which one? Sine over cosine or secant over cosecant?
Secant.
Okay. And the purpose there being, so the whole thing has secants and cosecants in it, I guess?
Yeah.
Okay. It's not a terrible idea. All right, we can do that. That, although we replaced like one thing with two and nothing cancels immediately, at least it's all the same stuff. Roman was next up, but he's gone. Vincent, you are next.
Now could you just click cancel?
So what are you trying to cancel?
Like the secant squared x and the cosecant squared.
So you can't cancel like those two because there's addition going on here, right? But you could do this because there's multiplication going on between, like, you know, those two pieces. So you could do that. That's okay to do. You see the difference? Okay. All right. So that's fine. We can do that. All right. Let's rewrite what we have now. All right. Ella, you are my next victim.
Can we simplify to get secant out of the 1 over secant and take the square out of the problem?
Okay, so you're talking about reducing, right? So it's not going to reduce, like, okay, so there is something you can do there with this, but it's not this, which I think is what you were saying. So what you'd want, the way you'd want to think about this, and this is a little tricky, is you'd want to think about like multiplying the top and bottom by secant. So when that multiplies to there, those can cancel, right? But this then multiplies to there, and we get a secant cubed. But that would be okay to do. You just, right idea, like wrong execution, I guess. But that's not so bad.
From there, we take the
Are you talking about reducing again?
Yeah.
So no, because we still have that addition going on in the numerator. So you're not going to be able to reduce from that addition problem. Oops. Do you have a different idea? I'm going to let you take another one because I can tell you're still looking at something.
Yeah, I'm trying to figure out if I should.
You certainly could. I mean, we can. I probably wouldn't. Again, because you're trading out like one thing for two, and there's no obvious canceling that's going to go out if you trade out like secant squared for tangent squared plus 1. That's fine, but like that doesn't allow us to cancel anything, or so I probably wouldn't. It's not wrong, it's just not really going in the right direction. We've now entered into, from the choices we've made, into like a tricky situation here where it's not obvious what to do at this point. This is what I would say. That stuff needs to get combined together. Now, they're not like terms the way they're currently written. So really the way that we end up combining them together is we're going to use R4 and R5 to rewrite that as like 1 over cosine squared plus 1 over sine squared. And then we'd need to make a common denominator in the numerator. So that would be like, I'd multiply this guy by sine squared over sine squared, and this guy by cosine squared over cosine squared. And what do you notice is going on in the numerator now?
It's still
That is an identity. Sine squared plus cosine squared, that's P1. And I know that's just equal to 1. And now the sneaky part, what we would do is I'm going to think about this 1 over sine squared, cosine squared is 1 over sine squared times 1 over cosine squared. That allows me to use R4 and R5 again to rewrite that. First one is cosecant squared, and the second one is secant squared. And finally, we're at a place where we can reduce now. So we're left with cosecant over secant. Which I recognize as Q2, which is just cotangent. Mr. Kulik, that was like impossible. That took so long. There were so many steps. Well, part of that was due to choices we made in the beginning. So the very first step we made, or we did, where we made the common denominator. Now, Naya did that correctly, but there's a different common denominator we could make here that would have made this problem massively simpler. The other common denominator we could have made is 1. That's the common denominator I would choose to make. What do I need to multiply cosecant squared by to turn it into 1? Not cosine squared, sine squared. Right? Look at R4. Cosecant is 1 over sine. So cosecant squared is 1 over sine squared. If I multiply that first fraction by sine squared over sine squared, the bottoms are just going to cancel out of there, right? What should I multiply the second fraction by to cancel the denominator? What is secant? Look at R5. It's 1 over cosine. So if I multiply this one by cosine squared over cosine squared, those guys just all cancel each other out, and we're left with a denominator of 1. Oh, I think I wrote down something wrong at the end of the previous line. We'll go back and fix it in a second. So that leaves us with just this. Now I'll factor out my tangent, just like we did on the previous one. Sine squared plus cosine squared is 1. So 1 times tangent is tangent. That's the easy way of doing it. That was a lot better. Let's see. Where did I goof up here? I don't know. We made some kind of goof up over here somewhere. Where did I goof? Because I end up with cotangent instead of tangent. Let's go back here and take a quick peek. That all looks okay. That's fine. That reducing is fine. That should be fine. Okay. Huh, I don't see it. Whatever. Maybe it's down here. Oh my goodness. Let's look real quick. Where did we make the little mistake? There's some place that we did it. Yeah, it's somewhere up here. That's the wrong answer. I'm not sure why. I'll have to look at it again. I'm not really interested in diving that way through it. To go back to show you the good shortcut that I used here. Yeah, Tommy, sure. To the good shortcut I used here. Let me explain to you again what I saw that made me think to do this, right? Because that's the piece that you want to see. Because man, Mr. Kulik, if I saw to do that, that problem looks like something I could have now done versus the other problem, which was like, that was a lot of really stinky algebra I had to plow through to get to the answer, right? When I see denominators that are like reciprocal guys, like secant, cosecant, cotangent, just multiplying them by their reciprocal to give you a common denominator of 1, that's often going to be the easiest route, is to just like, let's get rid of all the fractions we can as soon as we can. Does that feel okay? That's my cue. That's my little shortcut that I'm noticing. If I have to make common denominators, let's make darn well sure I can't just like make a common denominator of 1 instead of having to do it the hard way. You know what I mean, guys? Okay. All right, let's see. 11 is next. Where did you go? All right, my next victim is Alana. She smiled. She's like, I knew that was coming. Well, the program is set up with without replacement, so you're only going to go so long before you get called on. All right, identity or algebra? What are you thinking here? Good. What identity are you thinking? Yes. What are you using? Sine squared plus cosine squared needs to be 1. But Mr. Kulik, they're not right next to each other. Why doesn't that matter?
Because they're both like on top.
And they're both being added, right? Can we add 3 things in any order we want? Isn't like 1 plus 2 plus 3 the same as 1 plus 3 plus 2? Right, so I can switch them so they're next to each other and bingo, bango, bongo, there we go. Thanks, Alana, good job. Max Goss, you are next. What are you thinking, identity or algebra? Okay, what algebra thing would you be thinking to do here? How are you going to reduce the secant from the bottom? There's no secants in the top even to do any reducing with. Let me give you a hint here. There's no algebra thing to do with this step. We should be looking for an identity. And my cue for which kind of identity I'd want to use is I have addition, I have a 1, and I have something squared. Makes me think I should be looking with the Pythagoreans. Do you see the one that we need to use? P3, that's correct. 1 plus tangent squared is secant squared. And Daniel, finish this up here for us. Yep. Mr. Kulik, that one was so easy. Yup. They're not necessarily getting harder. They're just different. If you see good stuff to do right from the get-go, they're usually not too hard. The hard ones are the ones where it's like, I can't see what to do here, and you just kind of go exploring through the problem. All right, Abby, you are next. What should we do first here, identity or algebra?
Identity.
Great, which identity do you want to use?
The
OE5, great. And as long as you're using OE5, we might as well also use OE2. So can I ask a quick follow-up question here, Ab? What did you look at in this problem to know to use the odd-even identities?
The negative x.
Yeah, perfect. So that was Abby's cue to know that we should be using the odd-even identity there. All right. Next up, he's in the bathroom. We get to reload. Oh, that's weird. I'll have to look at that. Took me to a weird part of the code I wasn't expecting there. All right, Max Spevitz.
Okay.
We have secant x times cosine x. What should we do, identity or algebra?
I'm gonna have to do identity.
Yeah, you got two things multiplied together. There's not a lot of other option here.
This is gonna be one of the Pythagorean.
Do you have anything squared?
No.
Then it can't be a Pythagorean.
I'm gonna have to do both functions.
Nope. If you don't have a pi over 2 minus x inside, shouldn't.
So then, is it going to be Q1? Are they going to be two separate fractions?
I wouldn't be using a quotient because those are for tangent, cotangent. I'd be using either R2 or R5. Either one would be okay. So I can take, yeah, if I did R5, that allows me to write secant as 1 over cosine. Yeah. Just one. So if you have two things multiplied together like that, reciprocals and quotients are where you want to live, because the goal is just something's going to cancel something and just be left with one thing, right? So I'd be looking for a way to rewrite secant so it has a cosine in it, or a way to rewrite cosine so it has a secant in it. Either way, but that's my plan. $13 is my next one. Well, this is a longie. Sine alpha minus tan alpha times cosine alpha plus cosine pi over 2 minus alpha. All right. Who's going to be our next victim? Abby. We meet again so soon. Identity, algebra, which one? Okay. Great. Which identity are you planning on using?
C1.
With C1? Great. So that's going to allow us to rewrite that as cosine of pi over 2 minus alpha is sine. Lana, you are next. You can use identity again, absolutely. What identity would you like to use? As a hint, I'd be concentrating on this chunk. The tangent alpha times cotangent alpha is where I'd want to be using my identity. So I'd either be looking, oh, go ahead. You got it? Nope. No p's because there's nothing squared. So I'd be looking for a way to turn a tangent into something with a cosine in it, or a way to turn the cosine into something with a tangent in it.
Q1.
Yeah, Q1 is what we'd want to use. So tangent is sine over cosine. Okay. All right. Next, Cameron. What can we do next? Algebra or identity? Okay, what algebra thing do you see? That's good?
Would you reduce cosines?
Wonderful. All right, just like you saw last time. It's like the problem was searching you out. Okay, Cameron, bonus question. Can you finish this off for us then? Sine alpha minus sine alpha plus sine alpha gives us?
Sine alpha?
Yeah. Boom, boom. We're left with just one of them. There you go. Good job, bud. All right. Last one, number 14. Ooh, scary. All right, Sam, you're up. We have 1 over 1 minus sine y plus 1 over 1 plus sine y. Well, you can't because, again, the addition and subtraction. You can't reduce part of an addition or subtraction problem. Well, the odd evens are for like sine of negative y. So that's not going to help us out. I would do an algebra here. What algebra thing would you want to do? You could if they had a common denominator. The denominators are not the same, though. So what are we going to do? No. That's a solving technique. So unless the problem says solve for x, cross multiplication isn't going to be the option.
So we're not subtracting, we're not multiplying.
Well, we're going to make if we want to add these two fractions, they have to have
Like,
common denominator. That's what we want.
oh, so times the left by negative.
Oh, if I multiply the left by -1, I'd have -1 plus sine y, which is still not the same thing as 1 plus sine y.
Maybe make the other one, the right side negative.
So then I'd have negative 1 minus sine y, which is still not the same as the other one. If I have 1 over 2 plus 1 over 3, what's the common denominator going to be?
6.
How'd you get the 6?
Multiply.
2 times 3, right? Same idea here. What's the common denominator going to be? 1 minus sine y times 1 plus sine y. So we'll just multiply the first one by 1 plus sine y, and the second one by 1 minus sine y. Feel okay? No? Why not? What's holding you up? Okay, I will grant you that. Yeah. It's the same idea down here, right? We did like 3 over 3 times 1/2, and then like 2 over 2 times the 1/3. So if I look at it, like, this is kind of the same as that piece. You know, this is kind of the same as this piece. Yep. Sure. This is kind of like the same as that piece. And then, like, this one is like the same as that piece. See, it's still the same process. Like, there's a lot of symbol going on, but it's still the same idea. We're doing the same thing, right? Does that help clean it up a little bit? Okay. All right. So if we go ahead and write this now as a single fraction, I'm going to have 1 plus sine y plus 1 minus sine y over 1 plus sine y times 1 minus sine y. Oh, he's gone. Tomasino, you're up. What can we do with this nasty looking fraction here? Algebra identity. I think that's a great option because the identity doesn't seem like there's a good one to use here. Great. What algebra thing can we do? In fact, there's 2 good algebra things you could do here. Your hint is one of them is in the numerator and the other one is in the denominator. I have 1 plus sine y plus 1 minus sine y. What can we do with that stuff? Yeah, there's just like terms, right? So what do I get when I add that stuff together? So sine y minus sine y is 0. And we're left with then just 1 plus 1 or 2. Okay? The other algebra thing is in the denominator. What can we do in that denominator? It's not being added, though. It's being multiplied. What does that look like when I have two parentheses next to each other like that? Foiled, the other F word. So when I FOIL that out and I combine like terms, I get 1 minus sine squared. That is P1. 1 minus sine squared is cosine squared. And if I think about this as like 2 times 1 over cosine squared, 1 over cosine squared is, I can use R2 on that, nope, R5 on that, and that is secant squared. Except I think somewhere along the line my y's I wrote as x's. All right. How do you guys feel after today? Did this get better? Was it worse than when you started? All right. So your assignment from this is 7 through 14.
Oh, spectacular. Did we just do that?
It is what we just did.
Oh, so we just camera.
Wait, only 7 through 14? Hallelujah.
This is the first time we've ever taken notes. Nope. Swear to God, it's not. You don't know this is. Oh.